Hi dear students, I welcome you all. I am Dr. JCSRao, lecturer in physics from Government Degree College Raja. Today in this lecture, I will be going to explain solar thermal systems, principle of conversion of solar thermal radiation into heat, and the collectors used for solar thermal conversion, and especially about flat plate collector. We know that sun transfers energy in the form of radiation. Can you ever see that radiation? See here. If I am placing this convex surface towards the sun radiation, you imagine that this one is our earth surface, and when the sun radiation is incident on this surface, you observe here how the reflected radiation is showing here. Now I am rotating some with angle. You clearly observe how the radiation is dispersing throughout the surface. So in this way the sun radiation is dispersing from our earth surface. So the solar radiation can be captured and converted into useful form of energy such as heat energy and electrical energy. And the system which converts solar radiation into heat energy is called solar thermal system. And these solar thermal systems are used to heat fluids, that is water or air. And the main components in the solar thermal system are: the first one is collector. Here the collector captures the solar radiation and converts it into heat energy. And the second one is storage system. Here the heat can be stored in a thermal energy storage system for later use. And the last one is energy conversion system. Here the stored heat energy is utilized directly to heat fluids or convert it into electrical energy. The basic principle behind the heat conversion process is greenhouse effect. So what is greenhouse effect? It allows sunlight to enter but doesn't allow heat to escape. Let us understand what exactly is happening. Solar radiation can easily pass through glass, then the ground inside the glass house is heated up. When this ground is heated, it radiates thermal infrared radiation. Now, the glass material doesn't allow this heat radiation to pass through. So, the heat is trapped inside the glass house. And because of that, the temperature inside the glass house rises. This is called greenhouse effect. Now, the same principle is used in the solar thermal energy collectors. There are some devices known as solar thermal energy collectors used for collecting heat energy from the solar radiation. Those devices also works on the same principle. So there will be having the glass cover. It transmits short wave radiation, but it is a very poor transmitter of longer wave radiation. The glass cover will allow solar radiation to pass through it, and below the glass cover there will be a black color coated absorber which is absorbing solar radiation. When the solar radiation incident on this glass cover, then partly it reflected and partly transmitted. So when this solar radiation falls on this absorber, the absorber will re-emit infrared radiation which we called it as heat, and glass will not allow infrared radiation to escape from the device. So the temperature of the absorber increases again and again. This is the principle used in solar thermal energy collecting devices. So as more and more solar radiation comes, the heat energy of the absorber increases, and as a result the infrared emission from the absorber also increases. So this is the principle of solar thermal conversion into heat. Now let us understand through experiment. Dear students, let us assume that this is one greenhouse. Say this one is a glass house. When the solar radiation of visible light wavelengths and shorter wavelength infrared radiation incident on this glass cover partly reflected and partly transmitted. So that transmitted rays when incident on the bottom or the surface of the ground surface, then the earth receives, absorbs the radiation and it emits a longer wavelength radiation, which we call it as heat. So when that longer wavelength infrared radiation is reaching here, it will not escape from this glass cover because of this is opaque to longer wavelength infrared radiation. So it again reflects back. So in that way we can trap the heat in this greenhouse. So let us see. Assume that this is the solar radiation. When the radiation is incident on this glass cover, here partly it reflects and also partly transmitted. And this transmitted light is incident on the bottom surface, and here also it reflects some radiation, that is IR radiation. So to avoid the heat loss due to reflection, we have to paint black color to the absorber. Now I am placing black paper here. See how the absorption takes place. It absorbs all the radiations, and now I am removing, and again I am placing here. See how it is absorbing. See again. So the reflected radiation from the ground surface, that is longer wavelength infrared radiation, when reaches to the glass cover, the glass will not allow to escape and it reflects back. So inside the glass house, heat is trapped and the temperature increases. So to avoid the reflection loss heat, on the top of the glass cover, we have to paint with the magnesium fluoride coating, and also at the bottom surface we have to paint with the black coating. In this way we can trap the heat. So this is the principle of conversion of solar radiation into heat. Now we will discuss various types of collectors used for solar thermal conversion. So let us see what is solar thermal collector. It is a device which is used to collect by absorbing the solar radiation and converts it into heat. This heat energy further is used for heating fluids such as water or oil or air, and for cooking food and for generating electricity. Now solar thermal collectors are mainly classified into two types. They are non-concentrating collectors and concentrating collectors. Non-concentrating collectors receive solar radiation over a wide area, and the absorbed area, that is the area in which solar radiation absorbed, is equal to the collector area. So collector area and absorber area is equal for non-concentrating collectors. And the examples for non-concentrating collectors are flat plate collector and evacuated tube collector. So next type is concentrating collector. As the name indicates, in this type of collector, solar radiation will be concentrated to a small area. So even if the radiation is collected over a wide area, the collector radiation is concentrated to a small area. So here the collector area will be very much greater than the absorbed area. And the various types of concentrating collectors are parabolic trough collector, parabolic dish collector, central tower collector, and Fresnel lens collector. Now we have to study each of these collectors in detail. First, let us move on to the non-concentrating type collectors, that is flat plate collector. The flat plate collector is shown here, and this is the most common and simplest design for active solar heating systems to heat fluids in domestic, industrial and agriculture sectors.
These flat plate collectors are usually made in rectangular panel having area 1.7 to 2.9 meters square. And as they are collecting solar radiation over a wide area, they collect both direct and diffused radiation. We know that the solar collectors collect the energy from solar radiation and transfer it to a fluid. So, depending on the fluid used, these flat plate collectors can be classified into two types. They are liquid heating collectors and solar air heaters. If the fluid used is water or any other liquid, the collector is known as liquid heating collectors, and if air is used for transferring the heat, it is known as solar air heater. Now we will discuss this liquid heating collector. The main components of this particular device are transparent cover, black absorber plate, tubes carrying heat transfer fluid, insulated box, and casing. On top of this device, there will be transparent cover and is usually made up of glass. And for any other, radiation transmitting plastic or film can be used. But mostly glass is used as transparent cover. It may be one or more sheets. It receives and transmits maximum solar radiation to the absorber plate and opaque to the infrared radiation, that is for higher wavelengths. When solar radiation incident on this, the part of the radiation transmitted and part of the radiation reflected. So there is some heat loss. So to minimize the reflections from glass surface, it can be coated with magnesium fluoride. This is also protects the absorber plate from direct exposure to the weather. Second one is black absorber plate. Below the glass cover, there is an absorber plate. It absorbs maximum solar radiation incident on it through transparent cover. In order to increase the absorptivity, it is coated with black color. And the absorber plate is made up of copper or aluminum or steel. But due to high conductivity and resistance to corrosion, copper is generally using, although a wide variety of other materials can be used for air heaters. And below the absorber plate, there will be the tubes which carrying the heat transfer fluids, and these tubes are in contact with the absorber plate, and these are also made of copper or aluminum or steel. And all these tubes are connected to the header pipe at top and also at the bottom. Next part is insulated box. All the above three components are enclosed in this insulated box. Here, fiberglass or styrofoam can be used as insulators. Next one is casing. The entire assembly is enclosed in a casing in order to protect all the components from various weather conditions.
For flat plate collector, this is glass cover, and below the glass cover we have to place one absorber plate. I am taking here is an aluminum sheet, and below this absorber plate we have to place number of fluid carrying tubes like this. So these are all vertically arranged, and there is two tubes commonly attached to these tubes. This is for inlet and this is for outlet. And now to absorb the more radiation, we have to paint this with black color. So like this. And now this glass cover, absorber plate and the tubes, all these are placed in a thermally insulated box. Assume that this is thermally insulated box. Inside the box we are placing all these three like this. So in this way we can make the flat plate collector, and this flat plate collector can be placed exactly opposite to the sun radiation like this.
This is the flat plate collector actually looks like. This is the transparent glass cover, and below this glass cover there will be black color coated absorber plate, and under the absorber in contact with it there will be the tubes carrying heat transfer fluids, and under that there will be insulation. Here tubes are connected to common header, so we can see it. These are the tubes. Vertical lines represents the tubes carrying heat transfer fluids, and all these are connected to the bottom header. Here the cold water enters into the bottom header and then it rises upwards. And during their process, since these tubes are in contact with the absorber, so they get heated. Like this bottom header, there is another header known as top header from where it can be taken outlet. And this hot water comes from this top header outlet. So this is the basic working of solar flat plate collector. Now let us see what are the advantages and disadvantages of a flat plate collector. We have already said that it can collect both direct as well as diffuse solar radiation. So it is one of the best advantage. And the second one, they do not require sun tracking system. As they are collecting both the radiations, they can be placed in a horizontal position. So they need not be tracking the sun. And third one, as it is placed outside, it has to be made mechanically strong to withstand any atmospheric conditions. And the last one, it is simple in construction and requires less maintenance. Now coming to the disadvantages, the first one, it is limited to low temperature applications such as household water heating. And the second one, possibility of freezing of water inside the tubes. We know that water is the most effective heat transfer fluid. So, and if we are using water as a heat transfer fluid, there is a chance for this water to get freezed during cold climates, and there is a chance to damage the tubes. So this can be avoided by adding some anti-freezing agents like ethylene glycol, but this addition of anti-freezing agent reduces the heat transfer capability of water. And another solution for this is that after using the device, we can drain the water from the tubes and then we can refill it again when we have to use it again. Next disadvantage is corrosion of the metal tubes by water. We know that when water is flow through the metallic tubes, it will get corroded. And also, if we are draining the tubes and refilling it again, if we are using that procedure, when these tubes are drained, the air enters into the tube so that the oxygen in the air increases the rate of corrosion. So the corrosion can be minimized by using copper tubings. Use of copper tubing is one of the best solution to prevent the corrosion. Now coming to the applications of flat plate collector. This is used for the applications of water heating and space heating systems. It is used to heat water on large scales such as at hostels, at hospitals and also at military camps. It is also used in solar cookers, in drying process and also in distillation process. Let us see another type of flat plate collector.
Dear students, this is one type of advanced flat plate collector. We made this for demonstration purpose only. For that purpose, I have taken two absorber plates. One is this one and the other one is backside. These two plates are clubbed like this, and in between these two plates, we placed a number of tubes which carries the water. And all these tubes are connected with the common tube here and also in the bottom. So this is known as topper header and this one is bottom header. These two topper and bottom headers are connected to the storage tank. So where we have to store the water. And to absorb the more radiation, we have to paint this with black color Now I am placing instead of that this black paper like this, and this setup is completely placed exactly opposite to the sun's direction like this. Now when we put the water in this place, then the water, cold water comes down and flows through this common header, and in between these two plates through all the tubes it flows. So when the radiation is absorbed by this absorber and it converts into heat, and that heat will be given to the water and the water's temperature rises up. So when it heated up, the hot water, due to less density, it rises through this bottom header. So this hot water comes through this and enters into the storage tank. But here there is a water, cold water, and the hot water is also mixing here. But due to difference in density, the hot water flows in top surface, and the cold water, due to high density, it is coming down and flowing through this top header. Again it flows in between these two, and again it receives the temperature, and again it heated up, and due to less density it rises through this and reaches this one. So in this way the water is heated by using solar radiation. So this is also nothing but one solar water heating system. So dear students, you can do it at your home, similar type of experiments with low cost materials with a new innovative ideas. Thank you.